We have spent some time in class discussing motion in the x direction. We've looked at videos, analyzed the video, and we're able to create graphs that represent the motion of different objects. However, I want to stress the importance of being able to take a graph and, looking at the plot in the graph, being able to describe the scenario that would have created that graph. In this particular graph, we see three different plots, each representing a cyclist. The red is cyclist 1, the green is cyclist 2, and the orange is cyclist 3. Here we see three cyclists. The origin is set off to the side so that all cyclists will be traveling most of the time in negative space. In the background, a sawbuck was placed to scale the entire video. Cyclist 1 is moving towards the origin and has a little bit of a head start. Cyclist 2 is moving towards the origin a little bit faster and has a much greater initial position. Trying to be different, cyclist 3 moves away from the origin and is moving a little bit faster than the previous two. Now that you've seen the video and you saw a glimpse of the graph, let's make the connection between the graph and the video. The red line represents the first cyclist, so we're going to focus on that graph alone by stretching it out. This particular cyclist is moving towards the origin and is starting off into the negative. At the end, she reaches the origin. So, what we see here is the cyclist has an initial position that is negative, down here. Let's look at the next graph. In this particular line, we also notice that the green line has a lower initial position. Now, why is that? Why is this line way down here as opposed to the red line over here? Well, if we take a look at the video, this cyclist number 2 started from way over on the left-hand side. So, naturally, that cyclist had a greater initial position. He was farther away from the origin over on the right-hand side. He also traveled at a constant speed. This slope is slightly steeper. It's very hard to tell, but once you do some analysis, you can see using some of the tools that it is actually steeper. Let's look at the last graph, which is our kid that's going in the opposite direction. For this scenario, the orange line, the cyclist is starting at the origin and moving away from the origin, but in the negative. So when you move away in the negative, your slope is negative. When you move away in the positive, your slope is positive. When you move towards in the negative, your slope is positive. It's the opposite. When you move towards in the negative, your slope is positive. So it's always going to be keeping track of the sign. If we look at this cyclist's motion, we see that he starts at the origin and moves away. His slope is the steepest, so therefore that cyclist was going the fastest. So, let's review what we've learned so far. We've got an understanding of what the idea of an origin is. For position, it's 0, 0, and it's how we measure an object's position. It's the reference point. We've also talked about initial position. It's the starting point for any object, and that object doesn't have to start at 0, 0, or it doesn't have to start at the origin. We've talked about slopes, particularly on a position versus time graph. On a position versus time graph, the slope indicates how fast something's going. The higher the slope, the faster it's going. A slope of 0 means the object's at rest. We've looked at scenarios and converted them through video analysis to a graph, and we've also talked about a graph and how we would convert that or describe the scenario.